value 2, subtract x is equal to a negative 4. Should I do the two pieces, two equations like we've been doing on the others? No, you're going to say it right quickly. Professor, please, there's no solution. Don't do anything to it. There's no answer. And we discussed that earlier. You can't have absolute value equal to a negative. Okay, better, I think there's another B in your handout. Also, I did not, and I'm going to do it with your help here, letter D has absolute value of 2x plus 1 over 3x plus 4 equals 1. By the way, I forgot to put the absolute value. Did I forget to put the absolute value bars around that? Oh boy, got to put the absolute value bars around that. 2x plus 1 over 3x plus 4, absolute value equal to 1. Now this one can be done. When I set this up, it looks a little strange. It's going to look like this. 2x plus 1 over 3x plus 4 is equal to 1. Or, 2 here, 2x plus 1 over 3x plus 4 could be also equal to negative 1. It's doable, can be done. Now let's do it. Guys, on the first one, I would, this is me, to solve this equation, I would just quickly cross multiply. Now we're thinking that 1 as 1 over 1, which you could, and a fast way to do it, just do it that way and that way, called cross multiplication. And you're going to end up with 3x plus 4 is equal to 2x plus 1. If I finish that up and solve for x, I think x is equal to, see if I'm correct, negative 3. Real quickly. On the side, also another consideration. Let's do a negative 1 over 1. Let's write like that. I would, it's up to you, I'm going to do a quick cross multiplication. And you're going to end up with, be careful here, 2x plus 1 definitely. And in the other direction, looks like it's negative 3x minus 4. Let's see if you guys agree. I think it is. Solve it, and we end up with 5x is equal to, looks like a negative 5. Doing it quickly. X is equal to a negative 1, I think. True? Okay. So it looks like if I have no mistake, I could check these. But it looks like if I have no mistake, we're considering a negative 3, I think it was, and a negative 1. Branches. The truth? And then you can go back and actually replace those and make sure you check them. I'm not going to check all these, take too much time. Let me check real quickly, negative 3. Back in the original. If I take negative 3 back in the original, we can go here. 2 times negative 3 plus 1, that's a negative 6 plus 1, that's a negative 5. Down here, that becomes a negative 9 plus 4, a negative 5. And negative 5 over negative 5 is what, a 1? And the absolute value of 1 is 1, so that will check. And I'm assuming also if you check the other number, it might check, should check. We got 2 answers, no problem. Please tell me, is part 1 done? That's it, just some examples of how to solve an equation with an absolute value. When you see one of these on the exam next, or maybe on the quiz Wednesday next week, how could you miss it? You can't miss it. Unless you forget, there was one here with a negative 2 somewhere, and erase it, or negative 4. Maybe this, you might overlook it if you're not careful. This can't be done. There's no solution here. The others could get it done. Guys, any questions? Go for it.
Shouldn't we consider that the bottom part of the fraction so we make sure that it doesn't equal 0?
Beautiful. Hang on. Look at this. I'm so glad you brought that up. Look at this. He says, wait, Professor, also could you please remind the class that denominator cannot be 0 to begin with, or it's undefined. You couldn't even do absolute value to it. Well, that would happen if x were, if I solve this, I think if x is what? Negative 4/3? Yeah. So if x were a negative 4/3, I would have to reject it. Did we get negative 4/3 to be considered? Thank goodness we didn't. Well, I would have to mark it out. Thank you for bringing that up, absolutely. Okay. Now, after all that, this is the part that they really want us to do, close down chapter 2. This is what they want us to do. I'm gonna do it this way, then look at your handout. Guys, all this is done. Here's the critical part for calculus. They're saying, please do this in the next part of the absolute values section. Go back to your V-shaped graph. Let me just start on this. Just jump to it here. Go to the grid, put that V-shaped graph, absolute value graph, back on there. I will. Something like this. There's the absolute value V-shaped graph. We know what that represents. Now, on the side. Watch carefully. I love this. I don't think your textbook did this for you. I think this is for helping them. If you solve this, you would say quickly, Professor, my goodness, x must be equal to plus or minus 2 to satisfy that. Is that true? That's what we were doing. If I solve this, then we might have issues. If I have an inequality symbol, this, in fact, I'm going to throw a greater than or equal to on this one, we may have issues. No issue on the first one. May have some issues on the other two. So I'm going to do a visual for you, then expand upon it and show you what that handout is trying to tell me to do or tell you to do. Guys, I got the blue graph. That blue graph, you know, represents this. No problem. Now, visually, I got this done. That's this graph. Now I'd like to graph 2 on the same grid. Okay, well, tell me what, if I go to the grid there where the blue V-shaped graph is located, I say now graph 2, because I see a 2 in my problem. Does anyone know what the graph of 2 would look like? And I'll graph it. What is 2? If someone says go to the grid and graph 2. What do you think it means? Y is equal to 2. Hey,
It's just a straight line from on the y on when y is equal to 2.
he says, Professor, go up to 2. Right there. And draw a horizontal line. Everything's equal to 2. Draw a horizontal line directly across and have this to represent, slide on, this will represent y is equal to 2. Hey, you're correct. So I got the blue, absolute value. Red, 2. Everything's 2 up there. Now, can anyone be clever in this class and tell me the intersection points? Where does the blue and the red intersect? They intersect twice. So I need to label those for a reason in this demonstration. I see Miriam's hand going up right there. Right there is an intersection point. Miriam, name the points.
I believe that is 2, 2.
2, 2.
Negative 2, 2.
And negative 2, 2. 100%. Agree. 2, 2, negative 2, 2. Intersection points. Makes sense. Now, I'd like to answer this question. Now, since I'm using different colors, let me put that absolute value in blue. Just to match the colors here. Guess what this can be, or you can easily answer this inequality by looking at the graph and telling me, when is my blue graph below, less than, below 2. That's all it says. When is it below 2? The blue graph is below 2. I think you guys will agree, and mark my graph up a little bit here. Is it below 2 here? And all of this on the blue graph below that horizontal line. Now, can someone tell me when is that happening? From what to what? Go for it.
-2 to 2.
-2 to 2, and that's your answer. Visually, that's your answer. Now, the other one says, let me see if I can do this, absolute value, I'll put that in blue since I used a blue marker over there for the V-shaped graph. Now we got this, absolute value of x is greater than or equal to 2. What do you think that implies since I have a visual here? What am I gonna look at there to answer that part? Help me out.
2 in brackets.
Okay, well, over here, it tells me what, when is my blue graph, what, above or on 2? And we'll shade the little regions here where it's above. So when is my blue graph above the red? That's all it comes down to. When is the blue graph above the red? Let me first shade it and I'll try to get an answer. Is this little piece right here of the blue graph, will all that be above the red? Will this little piece here of the blue graph, all that be above the red also? That's what they're asking you to find. Now, tell me in interval notation, when is that happening?
So is it gonna be an open negative infinity to -2
Love it.
bracket?
Love it. Hang on. Oh, wow. Bracket. Okay, tell me more. Union.
There's a union from 2 to infinity.
Look at that. Is he correct? Based on the visual. Now, we don't have time to draw a visual each time we see one of these absolute value problems with an inequality. So guys, we need some rules to follow. I think the rules are gonna follow this demonstration here. And they'll have some rules to follow and try to answer those questions there. Who would like to read for me? I think on the handout, guys, I think there's a piece there that tells you a rule to follow. Is there a rule there to follow, guys? Tells you if something happens to this, tell me yes or no. If so, I need someone to read that for me and tell me from this demonstration, what are the rules? And I'll write those on the board and we'll try a few of these problems. Anyone have that? Who would like to read? Go for it.
You're talking about number 2, the absolute value u.
There you go.
If absolute value u is less than a is equal, sorry, less than or negative a.
Oh, less than A, right, like that?
Yeah,
And-
is equivalent to
Is it then, it's equivalent to, then, what happens?
-2.
Oh, I put a number in there. In fact, it's negative A on the handout, isn't it? Is it negative A?
Oh yeah, negative a.
Negative
sorry.
A is what, less than
Less than u,
U, oh, they use U, okay. Less than
positive a.
A. Is that what I said in my demonstration, except I used a 2 here for an example? And she's telling me the same thing, because the answer here was -2 up to 2. We have it in interval notation. Please tell me, guys, is this interval notation here, does it mean this? Are these two saying the same thing? And that's what she has given me now. So now I have a rule. So if it looks like this, absolute value is less than some positive constant, then you can rewrite it quickly like this and get the answer. Now, I may have, I'm standing here trying to create one in my mind right now, I may have one there on that handout. Well, did I supply you with one there from there? Was there an example?
An example of that?
Like, did I give you absolute value of something less than something to try to apply this?
The -3 absolute value of 4x plus 6 is less than 27.
Oh, wow, is that the first one?
That's not the first one. But it's the first one that's less than.
Oh, it's the first one that's less than.
Yeah.
Okay.
Oh, yes, my bad. Yeah, the 2x plus 5.
Okay, so tell me all together, what was it? Is there one on there just less than? Aiden, what is it?
It's the absolute value of 2x plus 5 less than 7,
Absolute value 2x plus 5 is what?
less than 7.
That's what she wanted, right there. Okay, guys, so now, based on my demonstration, based on the rule there, I guess, it's this. Where u is equal to 2x plus 5, a is 7, so quickly, you can say, Professor, that means this. Negative 7 is less than 2x plus 5 in the middle, less than 7. That's what it means, real quickly. Now to solve for x, no problem. It's combined inequality. In this case, I'm going to subtract 5 to all parts. Easily done. I think you'll end up with a negative 12. Less than, these drop out, 2x. Less than 2. Then what would you suggest now to get the x completely by itself? Divide by 2. So notice that 2 is positive. And you're going to end up with this. Now, can someone tell me in interval notation? There's the answer. What would that look like in interval notation to express the same thing I have right now boxed off there? Is it, help me out, negative 6 up to what? 1, open. There's the answer. How could you go wrong? I've said so many times, if you go wrong, I'm going to start writing on your paper. You went wrong. You went wrong. Now jump into the rule there, read the rule for me for the other case, and that is if,
U is greater than A.
okay, absolute value of u is greater than a, that means, or can be translated as, then,
Then is equivalent to U less than negative A,
beautiful,
or U greater than A.
there you go. You move back to what we're doing here, I was doing the same thing here. Same thing, different rule. Now, did I have an example close by there on the handout that may apply here?
B is greater than or equal to 1. It's the same, 2 minus 3x, greater than or equal to 1.
Okay, oh, is that the first one I placed on there?
That one is like B.
Okay, how about one that just says absolute value greater than a? Was there one on there for that?
Yeah, that was the negative 3.
Oh, it was, the first one? Okay, hang on. Oh, sure enough. I jumped right into it here. Okay, absolute value of, the sample was what? Absolute value, I'll put that here. 2 subtract 3x, no, it's fixed. Is greater or equal to 1. Right like that. That fits this rule. Now, can anyone tell me the way she read this to us, she read the rule to us? Can someone break that down for me and tell me what does that mean in this case? Right here. Apply the rule. I'll put it here so I got space. Any idea? It says greater or equal to 1, which looks much like this. And here's what should happen. 2 pieces. Go for it.
2 minus 3x greater or equal to 1.
Well, it says, the first piece says less than.
Less than equal negative 1.
Okay, that's, I put equal to, thank you. Negative 1, in this case, she's telling me, I agree there. Or, now tell me the second piece.
2 minus 3x greater or equal to 1.
You guys agree? There it is written. But I got another rules to follow here. And it all comes from this over here. Same thing here. And you gotta solve and solve each one of those. Now, if I solve the first one, be careful. Move that 2 over by subtracting. I think it's a negative 3. divide by a negative, reverse my symbol, and I think I end up with that. X is greater than or equal to 1. Yes or no? Or, there's a second piece. Solve this. Let's move that 2 over by subtracting. I think we end up with a -1. Divide by -3, reverse my symbol. X is less or equal to, what is that? 1/3. Is that true? I did it quickly. You guys will follow me, make sure I do not make a mistake in math there. Is that true? Yeah, that's the answer. Now let's put in interval notation. This one says in interval notation, bracket 1 through infinity. Union, there's another piece. This one says negative infinity up to 1/3 bracket. And there's your answer. There's your answer for this problem. Based on the rules. Guys, I think the rules are easily followed, but you gotta know the 2 rules. And it actually came from this. Okay. Let me see how close I am to finish this up, so I can finish up chapter 2 all together. Let's see if I had anything else here. Oh boy, I did. Hang on, hang on, hang on. Letter C. I have on the handout, it looks like this. Let's see if I can apply a rule here. And this is greater than -27. Okay. You cleaned up? Divide both sides first by -3. Divide each side by -3, and we end up with absolute value of what? 4x plus 6. I think the symbol reverses on me, and -27 divided by -3, 9. Now can I apply one of the rules? I think rule number 1 says it looks like this. I think the rule in your handout was written as, I'm trying to find, and all this work I'm doing, I hope I didn't erase it. Oh, it's right here. Here's the rule to follow. So with this help of the rule, rewrite this now as, here goes, easily done, -9 less than 4x plus 6 less than 9. So far so good? Solve this, subtract 6. As a professional like this, it looks pretty easy right now. This is -15. Less than, these drop out, 4x less than 3. Divided by 4. And I'm doing it fairly quickly since that's just basic arithmetic there. I have no mistake, looks like that. Answer in interval notation. This up to this. Are you finished? But you must know the 2 rules. I don't think we'll have any problem with that. I don't think we'll have any problem at all with that. Guys, any concerns at this point? Let me check and see if I need to do any more on that. Because I did these for a reason. Oh, yes. Darn it. The last one I'll be doing on the handout is letter F. I brought that in for a reason. Close this down. That looks like this. Let's see what applies here. Absolute value, x squared plus 2x. Less than 15. It's all x. I think it's the same rule I just used on the last one. I see a less than symbol, guys, I think it's the same rule. If it does, that means, as you read this to me, this means quickly, Professor, you can write like this. You guys agree? Is that what it means? Now, this one's not as easily done. That's what it means, though. This one's not easily done. That's why I put those together there on the handout, as this one was. one was nice, I just solved for x, got the x by itself in the middle, and I was finished. This one, not as easily done, because it's an x squared plus 2x in the middle. What I'm gonna do to close this down, to finally see what the answers are on this one, give me a suggestion. Not as easily done as that last one, go for it.
Divide into two parts.
I gotta do two parts here, I gotta separate. One part I'll do in red. Okay, Professor, you better separate this one. There's one piece. So call it number 1, negative 15, less than this. Now put the word and. And there's a second piece. Let's put the second piece in green. Please tell me, in that combined inequality, that's the second piece, which says x squared plus 2x, when I separate it, is less than 15. I've got some issues on this one. But that's it separated, I hope. You guys agree with the separation? Did I separate correctly? Now you gotta solve each one. To solve that first one in red, I would suggest, it's up to you, I'm gonna move that, let's move that 15 over. I'm doing the red. Let's move that 15 over, and think of this inequality as looking like this. 0 less than x squared plus 2x plus 15. Now what? On the red. What would you suggest I could do to go further? Got a factor? Put a factor? Yeah, if I try quadratic formula, it's not a factor. If I try quadratic formula, look what happens. I get x is equal to, I'm just -2 plus minus, here goes, square root. B squared is 2 squared, that's 4. Subtract 4 times A, which is 1, C, which is 15. I think I can stop there. And I'm going to end up with like 4 subtract 60. And end up with a negative underneath the square root, which rules this out. Can't even deal with it. Gone. Can't be tried. Can't do it. Maybe the green will be doable. As if it is. Move the 15 over on the green. X squared plus 2x subtract 15 is less than 0. Guys, this one will factor. In fact, I think it factors into that. Now tell me, how would you finish that up? See, I love it. I think we had something like this on the exam. I now turn to what? I heard sign analysis. This one is doable. Last one has been ruled out. The green one can be done. Hey guys, if I use sign analysis, no problem. That's nothing I want to point out on this as I leave it. My critical numbers, real quickly, are -5. I'll place that here to look at. And a +3. I'll place that here. They are both open. And then you know how sign analysis works. You go through and test a number in each one of the intervals. Let me do it quickly and see if I can figure out what integral does work. We've done it so many times. I think maybe in between works. You guys could try a number in between, out to the left, out to the right, but I think we do go through all that checking that we've done so many times. I think this piece in between works. Therefore, the answer is, if that is correct, and I think it is, -5 up to what? 3. They said, Professor, that's the answer to what? Answer to this. That's the original problem. So you're allowed to put in up here, and to make this a true statement, you're allowed to only put numbers in here for the x effect. You put something outside, it's not going to work. And then we did a sign analysis to find out. Now, whoa. I watch my students, when I score papers, and my goodness, my students come from all over when I get students, which I love, a variety of students. Some students come from local high schools, some come from other countries. and we all have little different methods, which I love. Like what Mr. Park did with that absolute value graph yesterday in his description. Beautiful. So we all think of it a little differently. A lot of my students think of this like this, and I give you full credit, there's nothing wrong with this. They're saying, Professor, I may have known this as sign tables somewhere. You call it sign analysis, which sounds more sophisticated. Sign analysis, you go to a number line, you test, all that, it always works. But then I have some students who say, and I've got a couple of students who do this for me, just wait, Professor, I know another approach here. That is, yes, there's a -5 here, there's a 3 here. I know this graphs into a parabola opening up that passes through. In fact, we're going to find the y-intercept. Replace the x by 0, I think it's down here at -15, if I need to. That's true, guys? And then make a real quick sketch for me, like this. It opens up, and we agree it's a quadratic, so it should be a parabola. It says, like this, Professor, these are the x-intercepts. It opens up, and then you're trying to answer the question, when is it less than 15? And Professor, this is less than 0. This is the piece that's below the x-axis, which means less than 0. That's what it says right there. That's the piece that's below. And when's that happening? From -5 up to 3. And then you do it graphically, which I love. And there's on that first test, some students were doing their inequalities with the graph. And I could follow with the graph, I can see that happening, absolutely. Guys, anything at all to ask about, or I don't think, are we finished with that part or not? I think we are. Let me see if I am. Oh my goodness, are you kidding? Miriam, that's about chapter 3, says, what chapter 3, Professor? Well, chapter 3 is a little different, but it's coming up here shortly, but we're going to get it probably after the break. I don't want to leave this, hang on. Did I? Let me see if I did. Close this down. My students know me, when I go through the textbook, I'm not satisfied with everything in the textbook. I search elsewhere. Oh boy. I'm going to close down this. Mr. Park. Arena. In your Math 7 course, when you guys discuss limits and the definition and the epsilon delta definition that they're going to see when they get Math 7, was there an inequality written somewhere in that definition for the epsilon delta definition?
Yeah, there was absolute value inequality.
Some absolute values, right, involved. Was it also a less than, greater than symbol in there somewhere? Was it? Do you recall what it looked like? Okay, so they're going to see it.
Yeah.
As soon as I mentioned epsilon delta, you said, Professor, Lord, I don't know what epsilon is. And delta, what is delta? I don't know what delta is. You'll find out what those are. And then they combine those into an inequality. What I want to do is close down. There's a few minutes we have left, but I need your help big time to close this down. This is nice, but here goes. I'd like to solve this inequality with your help. Usually, on your next exam, usually in the past semesters, I've given them one like this for an extra credit. And you might see why when I look at it. We look at it. Guys, I brought this in, I created it quickly, so I'm hoping the numbers work out. My goodness, they don't, I'm gonna be very, very, very messed up here. 2 is less than absolute value, 3x plus 1, less than 4. Now they're saying, please find all the x's that would satisfy that inequality. At random, if I just start selecting numbers, if I put a 0 in for x, do my calculation, I think this gives me a 1. The absolute value of 1 is 1. Now, would that satisfy that inequality all the way across? Is 2 less than 1? you're shaking your head yes. Is two less than one? Contact the school you came from. Is two less than one? No, so zero's out. I can let x be zero. I'm just randomly selecting numbers. Can I use 4? Let's put a 4 in. That's 3 times 4 is 12 plus 1 is 13. Maybe 13 works. Absolute value of 13 is 13. Is 2 less than 13? Yeah, that's true. Is 13 less than 4? Oops. That's not going to work. Okay, anyone, before I show you the entire set of numbers that might work, maybe nothing works. Does anyone have one at random that I can plug in there and it will work? It'll satisfy all the way across? Anyone have an idea? I'll try. Go for it.
1/3.
1/3. Wow, 1/3. So I put a 1/3 in there. 3 times 1/3, guys, is 1. 1 plus 1 gives me a 2. Absolute value of 2 is 2. Now, is 2 less than 2? Darn it, close. Can't use it. Go for it.
1/2.
1/2? Okay, I'm gonna put a 1/2 in there. Put a 1/2 in there, that's 3 halves. 1 and 1/2, 3 halves. 1 and 1/2 plus 1, I have altogether what, 2 1/2. Now, is 2 less than 2 1/2? Yes. Is at the same time 2 1/2 less than 4? He's found one that works. He's found one that works. Now, at random, can anyone give me another one? And then I gotta find all of them here with your help shortly. He gave me, what was that, 1/2? I tested, it worked. Does anyone have in mind another one just at random that you think might work if I replace x by it?
Minus 3 halves.
What, 3 halves?
Minus 3 halves.
Oh, minus 3 halves.
Yeah.
Okay, far about here goes. Do we put in minus 3 halves? 3 times, that's a strange one, let's do it. Like that, right? Which is negative 9/2. Right? Or like negative 4 1/2 plus 1. I think this is what, negative 3 1/2? Altogether, I think it is. Check and see if I'm correct, guys. Is it negative 3 1/2? I did it quickly. Do all the math, is it, guys? I think. Now, so all that inside there with your replacement is a negative 3 1/2. Now, is 2 less than negative 3 1/2?
Absolute value.
Oh, no. If I read this, I'm going to take the absolute value of this, right? And that's going to give me 3 1/2. So is 2 less than 3 1/2? Yes. Is 3 1/2 less than 4? Does his answer work all the way across? Is 2 less than, because he says take the absolute value of this, and you get 3 1/2. 2 less than 3 1/2 works. 2 is less than 3 1/2. At the same time, is 3 1/2 less than 4 works? You have an answer. So I guess there's only 2 answers. But once 2 gonna be 1/2, I checked it, it worked. Farabad says what? Of all the numbers, negative what? Negative 3 halves? It worked. So just place those 2 on your quiz for your exam, turn your paper in, and get your results back, and you got 0. I want all of them. Susan was just giving me 2 that work. I think there's an infinite number of them. That I don't know where they are. That's why I'm closing this down with this. Does anyone have an idea? A method. I mean a method. This is crazy. Rather than just sitting there randomly choosing numbers, which will take you all day and longer, there must be a method to this madness. So I'll hang one up. Yes.
Can you not just split it up like we did the last one?
Thank you. Let's first split it up. Here we go. Now let's see how far I get here before we take a break. We're very close to the break here. I'll do this one in green. Here goes, guys. 2 is less than this. And I'm going to do the other one in red for separation. And I'll put the word and here. The other one separate looks like this in the red. absolute value 3x plus 1 is less than 4. He's exactly right. I hope I separated those correctly. These are different colors. Now you're supposed to solve each one of those. Supposed to solve each one of those. Well, we just set you up because I'll probably have to continue this after the break. Now, keep in mind the original problem's this. That's the original. Okay, guys, before we do take a break through this, does anyone have an idea? What would you suggest I do on the green? How would you approach solving the green? Can I follow one of those rules back there? Or should I do something to it before I use one of those rules? Give me an idea.
Two is less than 3x plus 1.
Tell me again.
2 is less than 3x plus 1.
That's why I brought this in. Yes?
Would you algebraically subtract the 1?
You could, that's inside the absolute values.
Oh.
I can't do that. That's why I brought this in there. Cannot move that 1 around. It's caught inside there. I'll get some thoughts and then we'll take a break and I'll finish this up after the break. Yes?
Can you split it up again?
Oh, what, like what?
Like, using the rules over there, we've got, 3x plus 1 is less than -2. And 3x plus 1 is swap that, greater than -2.
Mary, I think that what you're saying is correct.
Okay.
But first though, before we take a break, and I'll finish this after the break, this one's turned around backwards to begin with, if I were to use one of the rules. Guys, if 2 is less than that, another way to think of this is that must be true. I just turned it around. Is that true? If 2 is less than the absolute value, common sense says the absolute value must be greater than 2. Is that true? And then I can now use, if I didn't erase this, which I did not, it now fits this rule here. I've got the absolute value on the left, greater than some number. Is that true? When I turn it around? Now that's what she was doing for me. She's going to apply that rule there, which has 2 parts to it. I know. And then when we get back from the break, here we go. I have not finished enough to solve this. Can anyone tell me, is the red one, oh my goodness, this is another V subject. Is the red one in fine form right now? Does it fit rule number 1, which was way back here, rule number 1, where that's this one. And that's writing quickly, before you take a break. I'm not gonna finish it up. Can anyone tell me, since this one's easier, the red, what does the red tell me based on the rule to follow, rule number 1? What can I say this is equivalent to right quickly? -4. Less than 3x plus 1. What else? That was easy. Done. Using that rule right there. The other one's going to take a little time, and then guess what we have to do afterwards? Then we have to put them back together. We've got to put those two solutions, we're going to finally get all back together to find where do they intersect. Okay, guys. We get a 15-minute break. Oh boy. So we'll see in about 15 minutes, which is like what time?